Hey everyone, and welcome. So you spent all this time in Unity, you've designed this absolutely beautiful 2D level, it's a perfect piece of art, but you've probably hit that point where you're thinking, how do I actually make this do something? Well, that's exactly what we're going to tackle today. We are going to take this gorgeous but totally static landscape and, step by step, turn it into a living, breathing, fully interactive world. And we're going to do it using Unity's physics engine, which is way more powerful and honestly simpler than you might think. So take a look at this. Right now what you're seeing on screen is, well, it's just a pretty picture, isn't it? It's got these really nice snowy hills, a great clean look. I put this together with Sprite Shape, which is an awesome tool. But here's the thing. That's all it is. A picture. Nothing moves. Nothing cares about gravity. You could fly right through it like a ghost. It's kind of like a beautifully painted backdrop for a play, but there are no actors. And, crucially, no laws of physics. It's a world without rules.
And this is where we're going. This is the goal. By the time we're done here, we're going to have a ball that actually rolls, that follows every single curve and bump of this terrain, all thanks to Unity's physics. We're about to turn that static image into a living, breathing, interactive playground. This is the magic we're going to build, and we're going to do it together.
All right, so here's the game plan. First, we'll look at our world without physics and just get it set up right. Then, we'll dive into some one-click collision magic. After that, we'll make a physics actor, fix a super common floating object bug, and then polish up the sprite textures. Finally, we'll talk about what you can build with all this. Let's get started.
Okay, first up, a world without physics. Now, I know we're all excited to jump into the cool physics stuff, but trust me, we got to do a little bit of housekeeping first. A clean setup is everything in a project, right? So we're going to start by just making sure our level is positioned correctly. It's a tiny step, but it'll save us from some major headaches down the road.
So, super simple stuff here. Go ahead and find your level object over in the hierarchy window, click on it. Now just hit the W key on your keyboard, that's the shortcut for the Move tool. See that camera icon right there in the middle of the scene? That's the origin 0, 0. It's just good practice to line things up with it. So just grab your level and drag it over so the start of it is right on top of that camera. Done. This just keeps things nice and tidy and means when we add new stuff, we know exactly where it's going to show up.
All right, section 2. One-click collision magic. So our stage is set, but it's basically a ghost. You can pass right through everything. We're about to fix that with something I honestly think is kind of magical. We're going to use one single component that will instantly read our super complex, custom-drawn shape and slap a solid physical boundary on it. This is where things get real.
Okay, make sure your level object is still selected. Now, look over to the inspector on the right. You're going to scroll all the way down to the bottom, and you'll see that big Add Component button. Go ahead and give that a click. A search bar pops up. Just start typing in Edge Collider 2D. You'll see it pop up in the list. Just click it. And that's it. You've just added the component. And boom! Just like that. Look at your scene. See that green line? It just appeared out of nowhere, and it's perfectly tracing the entire top surface of our crazy wavy terrain. That green line, that is now the physical ground. That's the edge that things will actually hit. Think about that. No manual tracing, no dragging points around for hours. Unity just did all of that heavy lifting for us in what, a microsecond? It's amazing.
But wait, it gets even better. This is the part that is so powerful. That green line isn't static. It's not just a snapshot. Watch this. If I go back to my sprite shape and click Edit Spline, I can grab any of these points and just change the world. Make a hill taller, carve out a new valley, and as I'm dragging it, look, the green collision line is updating in real time. It just flows right along with whatever I do. This is an absolute game changer for building and testing levels quickly. It's a massive time saver.
Okay, next section, creating a physics actor. So our world has solid ground now, which is great. But you know, a solid floor isn't very exciting on its own. We need something to actually interact with it. So it's time to create an actor. We need an object that understands gravity and knows how to bounce off that new edge we just made. Let's bring something to life.
All right, I've got a little challenge for you. Based on what you already know about Unity, how would you make a simple ball that can roll down this hill? Seriously, pause for a second and think about it. If you've got Unity open, give it a shot. There's more than one way to do this, so there's no wrong answer. It's all about playing around and seeing what works. Go on, give it a try, and we'll compare notes in a sec.
Okay, you back? Awesome. So what you do? I'm guessing a lot of you probably went into the hierarchy, right-clicked, and made a 2D sprite, maybe a circle, and that's a great way to do it. It's the standard method. You then have to add a rigid body 2D to make it obey physics and a circle collider 2D to give it a shape. totally works. But let me show you a little pro tip, a faster way. Instead of making a sprite, right-click, go to 2D Object, then hover over Physics and choose Dynamic Sprite.
So, what's so special about this dynamic sprite? Well, it's basically a physics object starter pack. It's built for exactly what we're doing. Right out of the box, it's got a circle collider 2D, so it has a shape. More importantly, it already has a rigid body 2D attached. And not just that, the body type is already set to dynamic, which is the setting that tells Unity, hey, make this thing fall with gravity and bounce off stuff. The gravity is already turned on and ready to go. It's literally a one-click physics object. No extra work required.
Okay, so I just made one. I'm going to rename it Ball just to be organized. Now I'll just drag it up here, kind of above the start of the hill. So think about it. Our level has its edge collider, and our ball has its rigid body and circle collider. All the pieces are on the board. This is it, the moment of truth. Let's hit play and see what happens. And yes, look at that. It drops, hits the ground, and just starts rolling perfectly down the slope. We officially have physics in our scene. How cool is that?
All right, next up, fixing floating objects. Now that first test was awesome, a total success. But if you look really, really closely, you might notice a super common problem. It's one of those things that can drive you crazy if you don't know what's going on. Let's zoom way in on our ball and I'll show you what I mean. This is one of those little debugging tricks that separates a good-looking game from a great-looking one.
You see that? Look right there. There's a tiny but definitely noticeable gap. The ball isn't really resting on the snow, it's kind of floating just above it. So what's happening here? Well, remember that green collider line? It's perfectly aligned to the raw geometry of our sprite shape. But our snow texture, the part we actually see, hangs down just a little bit below that line. So basically, our physics collider and our visuals are just a tiny bit out of sync.
Now, this kind of thing can be super frustrating if you don't know where to look, but I promise you the fix is unbelievably simple. Just select your level object one more time, go over to the inspector, and find that edge collider 2D component. See that property called offset? It's got an X and a Y. All we need to do is tweak the Y value. The easiest way is to just click and hold on the letter Y itself and drag your mouse to the left. You'll see the number go into the negatives. As you drag, watch that green line in your scene. You're just going to nudge it down until it sits nicely inside the visual part of the snow. For this sprite, something like, negative 0.31 looks about right. And now, when we hit play, perfect. The ball is nestled right in the snow, not floating above it. Problem solved.
All right, on to our last big topic, mastering sprite textures. So at this point, our physics are spot on, the ball rolls great, it sits on the ground perfectly. Now it's time to polish the visuals. Because look, a game that feels good is awesome. But a game that feels good and looks amazing, that's what we're aiming for. We're going to tweak how our terrain texture tiles to give it that really professional, seamless look.
So maybe I'm looking at this and thinking, the snow texture is a little too small. It's repeating a lot, it looks kind of busy. Easy fix. Select the level object again and pop into Edit Spline mode. Now just drag a big selection box around all the points on your spline, so they're all highlighted. With all of them selected, look over in the inspector, and you'll see a property called height. If you start increasing this value, watch the texture. It stretches vertically. This makes the pattern look bigger and less repetitive. It's a fantastic way to dial in the visual scale of your details without messing with the actual shape of your level.
Okay, so you might be watching this and thinking, hang on, how come your snow texture is tiling so perfectly? Mine always has weird seams. And that is an excellent question. I kind of cheated a little for this explainer and gave you assets that were already set up, but you absolutely need to know how this works. The real magic for this happens inside a tool called the Sprite Editor. It's where you tell Unity exactly which chunk of an image you want it to use.
So look at the left, this is the problem we've all run into. Your original image has these soft, faded edges, and when you try to tile it, you get these nasty, super obvious seams. It just shatters the illusion. Now look at the right. This is the fix. Inside the Sprite Editor, you can literally just grab these green border handles and drag them inward, creating a perfect, clean rectangle inside your image. You're telling Unity, ignore the fuzzy edges, just use this perfect rectangular tile. When you do that, you get a tile that can repeat forever with no breaks, and that's how we get that seamless surface.
And there is one last absolutely critical piece to this puzzle. Find your snow texture in the project folder and click on it. Now look in the inspector. See this setting called wrap mode? This has to be set to repeat. By default, it's usually on clamp, which just grabs the pixels at the very edge and stretches them out forever, which looks, well, it looks weird and smudgy. Repeat is the magic word here. It's what tells Unity to actually tile the image over and over. You need this for your ground, your backgrounds, anything you want to be seamless.
So, what will you build? Let's take a second to look back. We started with a static image, just a pretty picture. And now we have a polished, interactive world with real physics and great-looking visuals. Let's do a quick recap of all the new superpowers you've just added to your Unity toolkit.
Just think about what you're capable of now. You can literally draw any shape you want and, with one click, make it solid using an edge collider. You can whip up physics-ready objects in seconds using dynamic sprites. You know the secret to debugging those annoying floating objects by just nudging the collider offset. And on top of all that, you now know how to polish your visuals by scaling your textures and using the sprite editor to create perfectly seamless worlds. That's a huge set of skills.
So, that's it. You are now officially equipped to build your own interactive 2D worlds in Unity. You can create those rolling hills for a classic platformer, or maybe some twisty caves for an exploration game, or even a crazy bumpy track for a racing game. The door is wide open now, so the only real question is, what are you going to build first?